Hello and namaskar. Welcome and thank you so much for joining me today. Over the next 60 minutes, we are going to take a journey together from zero to understanding one of the most transformational technologies of our lifetime, generative AI. We have all used ChatGPT or asked Siri or Google Assistant a question, or perhaps use the AI feature in Microsoft Word or Excel that suggests how to complete a sentence. Almost everyone has used some form of AI already, perhaps without even fully realizing it. So today, we are going to pull back the curtain and understand exactly what is happening under the hood when these systems produce such remarkably intelligent responses. By the end of this video, you will be able to answer four key questions with confidence. First, what exactly is generative AI and how is it different from the traditional software you have been using for years? Second, how did we get here? What is the history that led to this moment in technology? Third, what is a large language model and what are the concepts like tokenization, embeddings, and attention mechanisms? And finally, how can you explore these models yourself using Microsoft Azure AI Foundry? And how does the choice of model actually affect the output you get? Think of today as learning how your microwave oven works, not to build one, but so you can use it confidently and choose the right settings for the right dish. In terms of AI, we will learn what we can do better using AI and not to build a new one. So, what is generative AI versus traditional AI? To understand generative AI, we first need to understand the differences between traditional software, traditional AI, and generative AI. These are three fundamentally different ways that machines produce output. Let's now discuss traditional software, which is a rule-based systems. Traditional software follows explicit instructions that a programmer writes. Every possible situation must be anticipated and coded in. The machine does exactly and only what it is told. A good example will be to think of an ATM machine. It can dispense money, show your balance, or change your PIN because a programmer has written code for each of those exact scenarios. If you want the ATM to recommend a good restaurant nearby, you don't have an option. It cannot do anything outside its programmed rules. Another great example is the automated IVR phone system you get when you call your bank. It basically tells like press 1 for account balance, press 2 for loan inquiries, and etc. This is pure rule-based logic. It cannot understand context or handle unusual questions. Now let's discuss traditional AI, which is learning from labeled data. Traditional AI, often called machine learning, is more powerful. Instead of following hard-coded rules, it learns patterns from data. However, it still solves one specific, well-defined task. You train it on labeled examples, showing it thousands of inputs and their correct outputs, and it learns to make predictions. A good example will be the IRCTC's fraud detection system that uses traditional AI. It has been trained on millions of transactions, some genuine, some fraudulent. It has learned patterns like if a user books 10 Tatkal tickets in 30 seconds from three different cities, that is like kind of suspicious. It then automatically flags such bookings, but the same system cannot write you a poem or explain what Tatkal bookings mean. It does just one job. Another example will be like Flipkart's product recommendation engine. customers who bought this pressure cooker also bought these items. That is supervised machine learning working quietly in the background. Another example would be like, for example, if you are searching for a mobile phone in Flipkart, while you are trying to buy that, you will also get recommendation for related accessories. So these are all like supervised machine learning. Yeah. Now let's shift our gears on generative AI, which is specialized in creating new content. Yeah. Generative AI is a completely different beast. It does not just classify or predict, it actually creates. It generates entirely new content like text, images, code, audio, video, etc., that did not exist before. And it can do this across a huge variety of tasks without being retrained for each one. Generative AI is trained on enormous quantities of data, not just labeled examples, but raw, diverse data from books, websites, research papers, code repositories, and much more. From this training, the model learns the deep underlying pattern of human language, knowledge, and creativity. If we talk about an example, let's say, imagine you have a new intern joining your team. A traditional AI system is like a very specialized employee who can only do one specific task brilliantly. A generative AI model is like a well read, highly educated, multi talented person who can draft an email for you, explain a complex GST regulation in simple terms, write a Python script to automate your reporting, and then translate the whole thing into Tamil, all in the same conversation. Moving on, let's talk about evolution from perceptrons to transformers. Now, let us take a brief but important journey through the history of AI, because understanding where we came from will help you appreciate why today's generative AI is such a remarkable achievement. 1950s to 1960s, I would say like that is the birth of this actual idea. The idea of intelligent machines date back to 1950s. In 1950, the great mathematician Alan Turing proposed a simple but profound question: can machines think? He devised what we now call the Turing test. If a machine can carry on a conversation that is indistinguishable from a human, we might call it intelligent. Yeah. In 1964, the very first chatbot, Elisa, was created at MIT. Elisa could stimulate a conversation using simple pattern matching. If you type like, say, I am feeling sad, it would respond, why are you feeling sad? It had no real understanding, to be frank. It was a clever trick with rules, but it astonished people at that time. Think about the early Rediff.com chat rooms from the late 1990s, or the very basic question answer bot that Indian banks started deploying around 2010. Those were like essentially Elisa's grandchildren, rule-based systems that could only handle predefined questions. Between 1970s to 1990s, I would say machine learning actually took the shape. Yeah, though the like maybe like through the 1970s and 1980s, researchers moved from rigid rules to statistical methods. The field of machine learning was born, teaching computers to learn from data rather than following explicit instructions. Neural networks inspired by the biology of human brain began to emerge. The idea was beautiful. Just as our brain has billions of neurons connected together, we could create artificial networks of connected nodes that learn by adjusting the strength of their connection. Your brain learned to recognize your mother's face not because someone programmed it with a maybe a rule book or something, but because you saw her face thousands of times and your neurons strengthen their connection. Neural networks work on the same principle. They learn from repeated exposure to examples. Around 2010, we started seeing deep learning revolutions. So, like in the 2010s, a combination of three things supercharged AI. Much larger data sets became available. Computing power, especially GPUs, became dramatically more affordable. And new deep learning architectures emerged that could process these data sets efficiently. This kind of led to dramatic breakthroughs: image recognition, speech to text, machine translation, all improved explosively. Translation tools started becoming genuinely useful around 2016. Voice assistants like Siri and Google Assistant moved from novelty to utility. From 2017 onwards, we are seeing the transformer revolution. The single most important milestone in modern AI came in 2017 when a team of researchers published a paper called Attention is All You Need. In it, they introduced the transformer architecture, the foundation upon which virtually every modern large language model is built, including the GPT-4, Claude, and others. The transformer was revolutionary because it could process language in parallel, understanding relationships between all words in a sentence simultaneously rather than one word at a time, and it could do this at a massive scale. From 2018 onwards, the size and capability of models grew exponentially. GPT-1 in 2018 had 110 million parameters. GPT-2 in 2019 had close to 1.5 billion, and GPT-3 in 2020 had 175 billion. Today's model have hundreds of billions to trillions of parameters. Think of it this way: if GPT-1 was a talented graduate fresher, GPT-3 was like an IIT professor with 30 years of experience across every subject. And GPT-4 is like having access to a panel of the world's best expert in every domain, available 24 hours a day, 7 days a week, for free or for minimal cost. Let's discuss what is parameters. Yeah, in the models like large language models, parameters are the learned numbers inside the model that actually store the knowledge. Think of them as the adjustable knobs or weights that the model learns during training. Think of parameters as tiny adjustment knobs inside the AI model. These knobs control how the model thinks and gives answer. During training, the AI adjusts these knobs so it can predict the correct answer more often. So let's discuss an example here, a simple example that will make you understand. Imagine you're making tea. Yeah, you adjust sugar, milk, tea powder. These are like settings that change the taste. In an AI model, parameters are like these settings. The model learns how to adjust them to give better answers. AI models have billions of such knobs, and by adjusting them during trainings, the AI learns language, grammar, patterns, and reasoning. Next question that might come to your mind: why do models have billions of parameters? Because our language is very, very complex. To understand stories, questions, jokes, code, knowledge, the model needs a huge number of adjustable knobs. More knobs mean the model can learn more patterns. Simply put, parameters are the tiny numbers inside an AI model that it adjusts during training to learn how to give good answers. Let's talk about key capabilities and use case. Yeah. So what can generative AI actually do? Let me walk you through the major capabilities with examples that are directly relevant to your business context. Natural language understanding and generation comes fast on the list. The most powerful capability is working with human language, reading it, understanding it in context, and generating clear, coherent responses. Let's say a large Indian bank has deployed a generative AI assistant that can read a customer's compliant email written in informal Tamilish, like maybe like a mix of Tamil and English. Understand the issue, look up the customer's account history, craft a personalized resolution, maybe like a response in formal English, and simultaneously flag the case to the right team for action. What used to take 24 hours and multiple human touch points now takes just under 2 minutes. Next on the list is summarization and document intelligence. Generative AI can read long, complex documents like contracts, financial reports, research papers, legal notices, maybe like white papers, much more, and extract the key information in seconds. Imagine the due diligence process when your company is evaluating a vendor contract. Your legal team might spend 2 full days reading a 200-page agreement. A generative AI model can read the same document in seconds, identify the key clauses, flag unusual terms, and produce a structured summary. Your lawyers can then focus their expertise on reviewing and deciding rather than reading and extracting everything. Then we have code generation and technical assistance. One of the most practically impactful capabilities is the ability to write, review, and explain code. This has already transformed software development globally. At many IT companies, developers are using AI coding assistants to reduce the time spent on boilerplate code, write unit tests automatically, and debug complex errors by describing the problems in plain English. Junior developers who previously needed senior guidance for routine tasks can now move significantly faster and more independently. Finally, content creation and personalization. Marketing, communications, training materials, customer facing content, all of these can be generated, personalized, and localized at scale. A company like Nika or Misho running campaigns across India needs product descriptions in multiple languages, customized for different regional audiences. With generative AI, what previously required a team of writers for weeks can now be produced in a few hours, reviewed and refined by a smaller team of skilled editors. Let's discuss how LLMs work. For that, we need to understand tokenization. Yep. Now we are going to go one level deeper and understand the actual mechanics of how a large language model works. I know the word architecture might sound intimidating, but I promise you by the end of this section, you will be able to explain it clearly to anyone. Let us start at the very beginning when you type a message to ChatGPT or any other AI model. The first thing that happens is tokenization. The model does not read your text the way you and I read it. It first breaks your text down into smaller units called tokens. So let's discuss what is a token. A token is roughly a word or a piece of word. In English, a token might be a whole word like customer, or it might be a fragment like un, ing, or a tion. Yeah. Numbers, punctuation marks, and spaces also become tokens. On average, 100 tokens in English is approximately 75 words. So, a typical paragraph of text might be around 100 to 150 tokens. Let us try this with an example. Yeah, the sentence "Namaste. How can I help you today?" So let's what we'll do is like let's look at the OpenAI tokenizer here, and then let's look at this one like "Namaste. How can I help you today?" So now, if you see here, we have close to like 34 characters, and the tokens used is close to 10. Now, if you see it here, it basically has become something like NAM. Namaste is broken down as NAM and ASTE. And if you see here, the comma is a separate token, and then you have this how can I, all these things are separate tokens. And the question mark is also a separate token. Yeah. So now if you see here, we have used roughly 10 tokens. Um, like again, like notice how even this word namaste is like broken down into two parts because it is less common in the model's training vocabulary. Yeah, the model has learned that this one NAM and that is whatever is followed by that ASTE forms a common greeting pattern. Why does tokenization matter to you? Because it affects cost and capacity. Most AI APIs charge by the number of tokens processed, and models have a context window, the maximum number of tokens they can process in a single conversation. Understanding tokens helps you design your prompts and your applications effectively and efficiently. Now comes the embeddings, and that is used to teach meanings to the machines. Yeah. Once the text is broken into tokens, the next step is converting those tokens into numbers because computers ultimately only work with mathematics. This is where the embeddings come in. Yeah. And embedding is a way of representing a token or a whole piece of text as a list of numbers called a vector. Yeah, but not just arbitrary numbers. The magic of embeddings is that words or concepts with similar meanings end up with similar numbers. The mathematical distance between vectors reflects the semantic similarity between concepts. Let's discuss a small example, yeah, so that we will be very clear on the vector and stuff. Yeah, so look at this map of India here. Yeah, every city has coordinates. For example, if you see here, Mumbai is at roughly 19 degrees north and 73 degrees east. And if you look at Chennai here, it is at 13 degrees north and 80 degrees east. Yeah, these coordinates are numbers, but they encode geographic relationships. Yeah, cities that are close on the map have similar numbers. Embeddings do exactly the same thing for meaning. Words like a doctor, physician, surgeon end up with similar embedding coordinates. Dog, maybe like a cat or nearby. But if you look at it, dog and democracy are kind of like far apart. Yeah. This means that when you ask an AI model a question, it is not just pattern matching your exact words. It is operating in a rich semantic space where it understands that your question about medical practitioners is also relevant to information about doctors and surgeons, even if those exact words are not in your question. Now let's discuss on attention mechanism, which is the heart of intelligence. Now we come to the most important architectural innovation in modern AI, the attention mechanism. This is a key idea from the 2017 Attention is All You Need paper that actually changed everything. Language is deeply contextual. The same word can mean completely different things depending on everything around it. Uh, Earlier, AI systems processed text sequentially, one word at a time, which meant they struggled to connect meanings across long distances in a sentence. Consider this sentence. Rajesh told Vikram that he had won the award. Who won the award? Rajesh or Vikram? You and I can figure this out from the context, tone, and broader knowledge. But for a machine processing one word at a time, he here is going to be ambiguous. The attention mechanism solves this by allowing the model to look at every other word in the sentence simultaneously when trying to understand any one word and to assign different weights of importance to different words. When the model processes he, the attention mechanism looks at every other token in the sentence and calculates how relevant is each word to understanding this word. It might determine that Vikram has high relevance to he and Rajesh has lower relevance based on patterns learned during the training. Let's discuss how attention works. Think of attention as a spotlight system when trying to understand any particular word. The model shines spotlights of varying brightness on every other word. Bright spotlight means this other word is very relevant to understanding the current word. Dim spotlight means less relevant. The model aggregates all the information from every other word, weighted by these spotlight intensifies to build its understanding. The transformer architecture has multiple attention heads, essentially multiple different spotlight systems, each capable of capturing different types of relationships simultaneously. One head might be tracking subject verb agreement, another might be tracking co-references like he or they, another might be tracking topic consistency. Think about how a skilled court journalist covers a complex parliament session. They are simultaneously tracking what the finance minister said about the budget, connecting it to what the opposition leader said 10 minutes earlier, noting how backbenchers' comment relates to both, and watching the prime minister's reactions. They are maintaining multiple threads of attention simultaneously. That is what multi-head attention does. We will discuss about foundation models versus fine-tuned models. With the understanding of the core architecture, let us now talk about how these models are actually built and deployed in practice. Because this distinction is practically very important for your organization. What is a foundational model? A foundational model is a large model that has been trained on a vast, diverse data set, essentially a huge cross section of human knowledge and language from the internet, books, academic papers, code, and much more. This training is called pre-training, and it is extraordinarily expensive. We are talking about months of computation. It can go to years as well on thousands of specialized chips costing millions of dollars. After pre-training, the model has learned general patterns across enormous range of topics and capabilities. Think of it as a highly educated journalist, uh, like who has read almost everything ever published. Examples include OpenAI's GPT, Google's Gemini, Anthropic's Claude, and Meta's Llama. These are all foundational models. Now, if you take an example, foundation model is like IIT Chennai. It is built at enormous cost and effort, trains people across many disciplines, and produces excellent generalists who can work in almost any field. The infrastructure investment is justified because thousands of students benefit from it. Now let's discuss about fine-tuned models. Yeah, fine-tuning takes a foundational model and trains it further on a smaller domain-specific data set. This teaches the model to be particularly excellent at a specific task or domain, while retaining its general capabilities from pre-training. Because the hard work of learning general language and reasoning has already been done in the pre-training, fine-tuning is relatively cheap and very fast. You are only teaching the model the specialized knowledge it needs for your use case. If the foundational model is IIT Chennai, fine-tuning is like sending that IIT graduate to a specialized MBA in healthcare management at AMS. They already have world-class analytical skills from IIT. Now they acquire deep domain knowledge in healthcare. The result is someone who can apply rigorous analysis to healthcare specific problems. Your organization can fine tune an existing foundation model on your internal documents, your domain terminology, your specific workflows, creating a model that behaves like a highly knowledgeable internal expert. Finally, let us discuss the choice between LLMs, the large language models, and the small language models, which is SLMs, because this is a very practical decision that your technology teams will face when deploying AI solutions. Let's first discuss on the large language models, LLMs. Uh, if you see like LLMs will have hundreds of billions of parameters. Yeah, if you look at GPT-4, it has estimated to have like 1 trillion parameters. Yeah, they're excellent at complex multi-step reasoning and creative tasks across all domains. Yeah, it has got higher compute costs and cloud deployment typically required. Yeah, use when breadth, flexibility, and high reasoning quality are required. And if we look at the small language models, it is comprised of billions of parameters. For example, if you see Pi 3, which is like close to like 3.8 billion, and Mistral will be like close to 7 billion parameters. Yeah. These are all excellent at specific, well-defined tasks with a focused domain. Yeah, they have lower costs, can run on premises or even on edge services. Uh, you need to use when the task is specific, latency matters, or data privacy requires a specialized on-prem deployment. Yeah, think of it this way. Yeah, let's say central government hospital in Bangalore needs a general medical practitioner who can handle any patient who walks in. That is your large language model. Yeah, but let's say a specialized tuberculosis diagnosis clinic in rural Jharkhand might only need a focused diagnostic protocol, a trained specialist AI deployed on a low-cost local device. That is your small language models, SLM. The right choice depends entirely on your specific use case. Yeah, we will see both types of models in the Azure AI Foundry demo coming up next, and you will actually be able to compare the responses to the same question. All right, this is a part I have been most excited about, and I'm pretty sure you guys will also be more excited. So, till now, we were like just on theory, but the thing is, like, you need to have this theory knowledge, you need to understand details of AI before doing some demos. Yeah, let us move from theory to practice. We are going to explore the Azure AI Foundry Playground live, compare different models, and directly observe how the architecture choices we just discussed actually affect the output you receive. We will first open the Azure AI Foundry. For that, you need to click on a new tab and then open ai.azure.com. Yep. So once you open this, you will see that you are on the Microsoft Foundry. Yeah. So this is the Azure AI Foundry, Microsoft's unified platform for exploring, building, and deploying AI models. It gives you access to hundreds of models from OpenAI, Meta, Mistral, and more, all in one place. Yeah. So what we'll do now is like let's click on this Microsoft Foundry, yeah, and it will take you to this particular page here. Yeah. So now what we'll do is like let's create a new project here. So let's click on this plus create new. Yep, and then I will have this recommended resource project, which is Microsoft Foundry resource selected, and then click on next. I will name this as JB Azure AI Foundry project. Yep, and then let's click on this advanced options. Yep. So the subscription, yeah, select it as per your requirements. Yeah, and then the resource group, I will create a new resource group. Yeah, I will not go with the default one. Yeah, and then uh, the Microsoft Foundry resource. If you want to change the name, you can go ahead and change that. And then the region, you can select whatever is required for you. Yeah, for me, I will use the East US too. Let's click on create. It's going to take some time. So what I'll do is like I will pause this video, and once the project is created, we will take it from there. Okay, so the project is created now. If you see here, this is the project that I've created, and the region is East US. Yep. So let's click on the project here, and then it will take you to this particular page. Yep. So now I'm interested on this particular piece here, which is called playgrounds. Let's click on that. So let's discuss what the playground is. Yeah. The chat playground is where we can interact directly with the AI models, experiment with different prompts, and compare outputs. Think of it as a safe sandbox environment. You can try anything here without it affecting any live systems. Let's click on this, try the chat playground. Yeah, let's click on that. And then if you see here, if you have any of the deployments already, you'll be able to select it from here. Yeah, so right now, I don't have anything. So what I'll do now as the first step is like I will click on this create new deployment, and then let me click on this from base model. Let's wait for the available models to load, and then we'll take it from there. We have close to like 99 models. Yeah, if you see here, like we have the GPT, Claude, Mistral, DeepSeek, everything we have here. Yeah. So now what I'm going to do is like I'm going to select one of the things here. I can select GPT 4o, which I normally use, but we have other things as well. Like if you see here, we have this GPT 5.3, we have GPT 5.4. So for example, if I select GPT 5.4, it is basically telling like registration is required, and it is asking me to request access. So I'm not going to select that. Yeah. Instead, what I'll do is like I will select maybe like this one, the GPT-5 chat here. Yeah. Or the best one is like GPT-4o. So let's go to the GPT-4o. So what I can do is like I can search for GPT-4o. Yep, and then if you see here, we have this. You can select whatever you want, but in my case, I'm gonna select this GPT-4o. I will click on confirm. So GPT-4o is currently one of the most capable generally available models. Yeah, the O stands for Omni, meaning it can handle text, images, and other inputs. This is a LLM, which is large language model with hundreds of billions of parameters. Yeah. So you can provide a name here. So in my case, I will provide the name as JBGPT-4o. But whenever you are deploying it for any specific AI solution, I would recommend you guys to have an appropriate name. Yeah. The next thing that you need to look at is the deployment type here. So for the global standard, which is right now selected, it basically tells like pay per API call with the highest rate limits. And note this out, like it basically tells like data might be processed globally outside of the resources Azure geography. So this is something that you need to make sure agrees with your requirement. Yeah. So because you can develop everything, but at the end of this deployment, when someone is telling like the data should be processed only in that region, then it's going to be a problem. So I would recommend everyone to look at different deployment type and then select which one is better suited for their requirement. Yeah. For example, if I select standard, this is what I'm seeing. Yeah. So it's a demo, so I'm gonna use the global standard, but please understand this is very, very critical, and then you need to select the appropriate one. Other things, yeah. So if you see here, this is a model version. I'm not going to change anything, this one or this one, but you have something like tokens per minute rate limit. Yeah. So now, if you see here, it is set at 100K, that is 100,000. Now you can increase it as per your requirements. Yeah. So the thing is like when you increase your number of tokens per minute, yeah, what happens is like the response that you're gonna get is going to be better. For example, you have a lot of users using this model, and let's say a lot of users are asking so many questions. Yeah, when you have the number of tokens higher, what happens is like the response that you're gonna get for these users are going to be comparably good. But now let's say we're gonna reduce it. Okay, so let's say like to 100K. Yeah. Now what happens is like there is a possibility when you have a lot of users using this deployment, there is a possibility you might utilize the available tokens. That is, the tokens per minute is like 99K right now, and in case if it is utilized, then what happens is like the response will be like not that great. So till the tokens come back to its normal, for example, you have to basically wait for the next minute wherein it will replenish the tokens, and that is when you will get it. So it all depends. Like when you have a lot of tokens, the response is gonna be very good if you have really users using that many number of tokens. Yeah, but the thing is like when the token usage is high, your cost with respect to this particular deployment will also be high. So that is something you should keep in mind, and then you need to select, like you need to have that balance between cost and performance. Yeah. So I'm going to click on deploy here and wait for it to get deployed. So if you see here, it is deployed now. Now, if you see here, this one is no longer disabled. I'm able to see that the JB GPT-4o, which I've created, is visible here. Yeah. So now you have this model instruction. So right now, I'm not going to change anything. I'm going to have this default one, which basically tells like you are an AI assistant that helps people find information. Now what I'll do is like I will ask a simple question that's basically explain the concept of compound interest to a 10-year-old child using a simple Indian example. This is what I'm going to ask. So now what happens is like when I ask this, I have the response here. So again, the question asked is like explain the concept of compound interest to a 10-year-old child. So now if you see here, it basically tells like imagine you have a piggy bank and you put 100 rupees in it. Yeah. And then it basically tells like your money will grow 10% every year. So year one, It's basically telling like 10% of 100 is 10, and then you will get like 110. And second year, it's going to be again 10%, but it's going to be on that 110. Yeah. And this time it will be like 11 rupees for the second year, and it is going to be altogether 121 rupees for the second year. And now, as far as third year is concerned, now we get the interest of 10% on that 121, and the interest there is like close to 12 rupees. So altogether it is like 133. Yeah. And then it is telling like this keeps going every year. Your money grows not just on the original 100, but also on the extra money, that is the interest you earn. Okay. And it is also telling like why it is important. It basically tells like in India, people use compound interest to grow their savings in banks. Yeah. So it's pretty clear. I'm pretty sure like anyone can understand this, and I would rate that this particular response is really, really good. Now what we'll do is like now we use this GPT-4o, which is an LLM, large language model. So now what we'll do is like we will create another deployment here, but this time instead of selecting a large language model, we will select a small language model. I will search for Grok 3 Mini, and I will select that one. Okay, so let's click on confirm here, and then just take care of the deployment type. Yeah, and click on customize, and if you can see here, you have the tokens per minute here again. Yeah, so I think like I should be okay with like 100,000 again here as well. Yeah, so I will select like 101,000 and then click on deploy here. Okay, and once the deployment is completed, what you will see is like under the deployment, you will now have two deployments. Yeah, one is for your GPT-4o and another one is for Grok 3 Mini. Okay, let's select this Grok 3 Mini. And now if you look at this, you have this give the model instruction and context. Like we will go with the default one wherein it tells like you are an AI assistant that helps people find information. Now what we'll do is like we will ask the same question as last time. Okay. So now I've selected Grok 3, and then now let me ask the same question now. And if you see here, Azure AI Foundry, it is telling like uh, Grok 3 Mini. Yeah. So now if you see here, we have the response here. Yeah. And then if you read it, it basically tells like I would be happy to explain. And then it basically tells like imagine compound interest as a magic trick where your money grows by itself. And then it tells like it is like planting a seed and things like that. But if you look at the actual details here, it basically tells like you start with rupees 100, the bank gives you 10% interest, and that means like it is going to be 110. Second year it's going to be 121. So pretty much the same response. Like if you look at it here with GPT-4o, you can see that it basically tells like year 1, year 2, year 3. But if you look at the basic crux here, it basically gives the same information. So I would say like the way it is presented is different, but the meaning seems to be like the response seems to be the same. Yeah. So that's on the Grok 3 Mini SLM. Smaller models are faster and cheaper to run, but the trade-off is in-depth and nuance of reasoning. Let us see when we compare the results here, like what I'm able to see is like the one that from GPT-4o is like highly presentable. But if you look at the response, it's like more or less the same as far as the end answer is concerned. I would say the smaller model has given a perfectly adequate answer for this simple query. Yeah. But for complex reasoning and nuanced explanation or multi-step tasks, the larger model typically demonstrates superior capability. Yeah. So this is the practical difference between LLMs and SLMs that we discussed earlier. what we'll do now is like I will switch back to the GPT forward deployment, and then what I'll do is like I will change the model instruction here. Okay, so I'm going to uh, write this particular model instruction, which basically tells like you are a helpful AI assistant for a large enterprise organization. You only answer questions related to Microsoft SQL Server, including database administration, performance tuning, TSQL queries, and things like that. Yeah, and uh, if a user asks about topics outside SQL Server, politely inform them that you specialize only in SQL Server. So I would say like this is an AI assistant for SQL Server. Anything outside of SQL Server, it's not going to answer. Okay. Now that I've put the instruction here, I'm going to click on Apply Changes, and then what I'll do is like I will ask a couple of questions here. I would say that this system prompt is how you fine tune the model's behavior for your specific use case. Yeah. Uh, Without kind of like retraining it. You are giving the model its role, its scope, its persona. This is the foundation of how enterprises deploy AI assistants tailored to their specific business context. Yeah. So the instruction plays a vital role. Yeah. So how good your model is gonna give you proper response, it all depends on the model instruction. Okay. The first question that I'm going to ask is like write a SQL query to find top 5 customers by total sales amount from an orders table containing customer ID, order date, and total amount. That's the question I'm asking. Let's see like what is the response we're gonna get. Now, if you look at it, it basically gives this particular query. Select top 5. So what I understand is like whatever we have asked, we got a proper query, and also it has provided us the explanation like why we have this query. Okay, so the next question that I'm going to ask is like I'm going to ask it to rewrite a slow running query. Yeah, if you see this SQL query is running slowly. Suggest ways to optimize it. Yeah, now let's look at the response. Yeah, and if you look at it, it basically tells like the query you provided may run slowly due to inefficiencies in how SQL Server processes the year order date. So this one, it basically tells like it is like is not proper because and lack of proper indexing. Yeah, so it basically tells like you can rewrite this query. Instead of using this, it basically uses order date greater than equal to and then order date less than. So this way, we will not have any issues using the indexes there. Yeah, and it is also telling like we need to create an index on this order date column, and it is even giving us the create index statement. Yeah, and it is also telling you can use this or you can create a covering indexes also, and it is additionally telling like check the statistics and then also look at the execution plan. Yeah, and it is also providing you other options here like do a partitioning. It depends like what is the table size and things like that, but yeah, these are the recommendations that you are getting it here. Okay, so now this is like more than enough for me to check all these things on a non-production server and then see which one is gonna help me to optimize this query. Yeah. So now what I'm going to do is like I'm going to ask the next question something outside of SQL Server. So I'm basically asking like which month is the best time to visit Chennai, and let's see what the response we're gonna get. Now, if you see here, it clearly tells like I specialize only in Microsoft SQL related topics, and it is politely telling like we need to reach out to a travel expert or consulting a reliable travel resource. Yeah. So this way, we have made sure like this AI assistant is just for answering SQL Server related queries. Now that we have discussed these things, what we'll do is like let's look at this token here. Yeah, so till now what we are seeing is like we have used close to like 1053 tokens. Yeah, this is what we have used. Okay, what I'll do is like I will ask this question. I'm asking like a simple one: what different versions of SQL servers are available as on today. And now if you see here, 1053 tokens have now changed to 1065. Let me cut that, and you see this, you have like 1053. Now as soon as I put these questions, you remember I showed earlier like how tokens are generated from the text provided. Based on that, it basically has calculated like it requires 12 tokens for this particular text. Okay, so now it is 1065. So let's run this and then see the response here. Okay, so if you look at the response, while the response is coming in, if you look at the tokens, it is slowly increasing. If you are seeing, yeah. So it basically like when you ask a question, it will be like sent as a token. Now the output that is the response that you're getting from the model is also like calculated as tokens. Yeah, that's the reason we can see that now the token count has increased to 1796. Let's have a brief discussion on two practical dimensions where generative AI delivers clear value and where you need to be thoughtful about its limitations. First, let's discuss on where AI delivers clear value. From what we have explored today, generative AI delivers most clearly in situations where you need to process large volumes of unstructured text, where the task is cognitively repetitive but requires language intelligence, or where personalization and context sensitivity matters. Some of the examples would be like document summarization and information extraction from large corpora of documents. First draft generation for communications, reports, and documentations. Next would be like customer service augmentation, like handling tier one queries while escalating complex issues. Code assistance and automated testing for software development teams also comes in the list. Finally, knowledge management, making your organization's internal documents searchable and queryable. Yeah. Let's now discuss where you must exercise caution. That would be mostly the hallucinations. Yeah. But I want to be transparent about a very important limitations here. Hallucinations. AI models can sometimes generate responses that sound completely confident and authoritative, but are factually wrong. Yeah. The model does not know what it does not know. It is optimized to generate plausible text, not to verify factual accuracy. Imagine asking an AI model about a specific Indian court case or a recent RBI circular. Yeah, the model might generate a response that sounds perfectly formatted and credible, citing specific section numbers, dates, and rulings. But if that circular was issued after the model's training data cutoff, the model is essentially making up plausible sounding details. This is called a hallucination, and it is why you should never use AI output without verification for high stakes decisions involving legal, medical, financial, or compliance matters. The good news is that there are architectural solutions to this, including retrieval augmented generation or RAG, which we will cover in a later session. RAG grounds the model's responses in verified current documents from your own knowledge base, dramatically reducing hallucinations. Let's talk about data privacy and security considerations. Another critical consideration is your data privacy. When you send text to a public AI API, the text passes through external servers. For sensitive business data, customer information, financial records, confidential strategy documents, you need to think carefully about deployment architecture. Azure AI Foundry, as you have seen today, addresses this through enterprise grade deployment options where your data does not leave your Azure subscription and is not used to train any external models. Your organization's IT and compliance teams will need to assess the appropriate deployment model for different use case. Moving on, let's do a quick recap of what we covered today, and then I will give you a preview of what is coming in our next session. In the last 60 minutes, you have learned that generative AI is a fundamentally different example from traditional software and traditional AI. It creates new content rather than following rules or making classifications. You have traced the history from ELISA in the 1960s to the transformer revolution of 2017 to today's extraordinary models. You now understand the three core architectural concepts: tokenization, which is how text is broken into processable units; embeddings, which encode semantic meaning as mathematical vectors; and the attention mechanism, which allows models to understand context across entire passages of text simultaneously. You understand the distinction between foundational models and fine-tuned models, and you can now make an informed judgment about when to use a large model versus a small model based on the specific requirement of a use case. And crucially, you have seen all of this in action live in Azure AI Foundry. You have watched how changing the model and the system prompts directly changes the output. In our next session, we are going to significantly deeper on something you have already been doing today without perhaps fully realizing it: prompt engineering. You will learn that the way you phrase a question to an AI model is not just an ICT. It is a technical skill that dramatically changes the quality of the output you receive. I will cover the key principles of effective prompting, including zero shots versus few shot prompting, chain of thought techniques, and how to design prompts for consistent, reliable enterprise use. Generative AI is not magic. It is mathematics applied at enormous scale to the patterns of human language and knowledge. The models are extraordinarily capable, but they are tools. Like any powerful tool, they produce excellent results in the hands of someone who understands what they are doing, and potentially problematic results otherwise. Your investment in these sessions is precisely building the understanding you need to be effective and responsible users and leaders in an AI-enabled organization. That's it for this video. Thanks for watching. Have a great day. Jai Hind.